Okay, this is going to be a clarification about this updateweights function, which is in section 1114, neural networks R code. So if we look at the updateweights function, we can see that there are 1, 2, 3, 4, 5 arguments. So the first one is the x value. So that's the input into the neural network. And then there's a weight W1 and a weight W2. So this is to be used in the 111 architecture. And then there's an output value and a learning rate. So this assumes that we either have labeled data, which means that we have an x value and a corresponding y value. So we know the true y value, and then we're going to make a prediction and then use that error to update the weights. So we can see down here that the x value will be multiplied by the weight, the first weight, and then pass through the sigmoid function. And then that will be multiplied by the second weight, which will be passed through the sigmoid function to give us a prediction. And then here, we're going to take the y value, which, as I said, we assume that there is a label for x, or a correct y value. So we're going to take that and calculate the error and so on. And that will enable us to calculate delta 3 and this derivative and this derivative. And then we can update the weights using those two derivatives. And then we're going to take those two updated weights and put them in a list and then return that list. So here we run it, and here I presume that there must be a weights vector already defined, which is actually defined up here. And so we can access the first and second elements, and those will be the weight for W1 and W2 respectively. And we also are assuming that the labeled value, the input value, in this case, the way we're using it, we're saying that the input is x and the output is this y, and the learning rate is that. And we just said that this is going to return a list. So we are running this and assigning its output to this, which is just a variable. But since we're assigning it, since the output is a list, this is going to, whatever we call this, it's going to be a list. So I just decided to name it list because it's going to be a list when we run this and assign it to that. And then, since this is a list, we can access its elements with weight list 1 and weight list 2 and assign them to this weights vector, which we initially was like this, but now it's going to be updated with the new weights. So the original weights were here, and the new weights now are here, so they have changed. And they changed based on the fact that there was some error, and that caused us to be able to calculate the derivatives and then update the weights. Now in the next section, we read in the entire data set. So if I scroll down, we're going to do this inside some function. We're going to define this function. It's called prediction for a neural network for a single value. So that name is a little bit strange since I just said that we're going to read in the entire data set. So let's see what happens. So just to jump ahead just a little, inside this function you can see that there's a for loop. But inside that for loop we are using this update weights function that we just described. So in other words, we're going to be running this update weights function multiple times. So the question is, for what values are we going to repeat it? So let's look at the parameters for this function. And we can see that it has something called input capital X. It has something called output capital Y. It has an X value, and it has a learning rate. Now, you can see from here that it seems like, anyway, that for this input, we're going to put in something called points, which, if you've read the earlier part, you know that that is an entire vector. You can see here points is the training data, the points variable. And then we do something, and then the same thing with price. The price is the training data price variable. So from the default values here, it's suggesting that, given that where this appears in the text, it's suggesting that we're going to feed in a whole vector here and a whole vector here. Now, the whole vector here is going to be referred to in the code as this, because this is the parameter. And the whole vector here is going to be referred to with this name, because this is the parameter. So let's look for where this is referenced and where this is referenced. So it's input capital X and input capital Y. Where are they referenced in this code for this function, for this function? So going back to this for loop, we can see here is input X. So this is an entire vector. So what we're doing is this is just a name. So what we're doing is we're grabbing each element from this vector and we're going to manipulate it in some way. So within the manipulation of it, it's going to be each element is going to be referred to as input. So what are we doing with each element? So it's going into here. So that's the X value for update weights. And then we have the weights. And then we have current price. So what is current price? Well, we have a count variable, which originally was 0, and then we update it within this loop. So for example, in the first time, count will be 1. So count is 1. And remember, this is the output variable. In the example, it's price. So this would be the first element of the price vector, and we'll call that the current price. So now, within this for loop, we're going to take the first, for example, the first input value, which means the first point, and then we have the weights, and then the first price, and this will enable us to update our weights. And then we're going to assign those new weights to this. And then we're going to assign a weights vector to this. And then we're going to go back and get the next element in the points vector and use that and the corresponding output associated with that to update the weights again. So we're going to repeat this for the entire points vector. So in other words, for the entire data set. So we're going to run that loop that many times. Now what are we going to do? What else were the inputs here? We have this one. We've talked about that. We have this one, but we also are allowing a X value be an argument in this function as well. So what are we going to do with that? Maybe confusing notation. So this is called input X, and this is called X value. So what is X value? So X value is after we've trained our weights or our network, after we've updated our weights many, many times, one time for each element of the data set, then we're going to use this. So how are we going to use it? So we do all the training by calling update weights, and we do all of that within this loop. So we do all the training within this loop. Once we've done that, then we take that X value that we just talked about here, this X value here, and what do we do with it? We have the weights now. We push the X value through the network. So we multiply it times the first weight, we get Z2, put that into sigmoid, multiply it times the second weight, and output a Y hat. So we're making a prediction based on the new weights that we've generated by training the entire, using the entire data set to train the weights, train the network. Now we're taking that value that we had here, which just happened to set it at 0.9, but you could set it at anything. We're going to put that into there and push out a Y hat. So push out a prediction for that 0.9. And so we're going to say the number of rows. The given input was the original X value, that is this thing here. And the corresponding prediction or output is going to be Y hat, and that's here. So that's the nature of this function called predNNSingleValue neural network for a single value. Even though we're using the entire neural network to update weights, then at the end, after we've done all the updating, then we'll just take this value and say, oh, let's see now, what would our network predict given an x value of 0.9 for the output or for the prediction or for the y value. So we can run it by putting points in there and price in there and say 0.9, for example, and see what it outputs. So here it says that if you put in 0.9, the prediction is this. And here it says that if you put in 0.2, learning rate is kind of strange, you'll get this value, and so on. And again, we don't really expect too much out of this network because this is all being done for a 1-1-1 network, which is not really, basically useless. But so what? We're just trying it out just to see what will happen. But really, a 1-1-1 network is like nothing. Right? Normally, networks are much, much more complicated than that. So just to clarify once more, function here takes one input vector, one output vector, trains the weights, and then we'll make a prediction based on a value here.